Namaste. Welcome to my second tutorial. I am Mohangiri. In this tutorial I will be talking about the bisection method for finding root of any equations. So first of all, let me say something about the root of the equation. Suppose we have any equation f of x, and I want to find the root of the equation. Then the root is defined as the particular value of x at which the given functional value will be equal to 0. So for that value of x at which functional value equals 0, then that is the root of the equation. In this tutorial I will be talking about the finding root of the equation by using bisection method. Okay, so bisection method is based on the principle of mean value theorem, in which the basic condition or basic requirement for finding root of the equation using bisection method is we will have 2 points or 2 values of x in such a way that the functional value of this f of x at this point and f of x at this point that means this should have opposite sign. For instance, if f of x has functional value f of a1 as positive, then f of b1 should have negative, or vice versa. So the given 2 points should have opposite sign of functional value at these 2 points. Okay, so basically we can find bisection method we can find root of the equation by using bisection method. This is the theory. Now let us move how we can solve this problem by using Fortran code. So for writing some codes on the Fortran, we should have some algorithm. Okay, so first of all, what we do is, first of all, we give 2 points or 2 values of x, a and b. Okay, make sure that the value of function at point a and value of function at point b should have negative value. It does not matter f of a should be positive or f of b should be negative or vice versa. We don't care about that, but the functional value should have opposite sign. Okay, so first of all we give input a and b, and then we define a point c in such a way that the point c lies in between a and b. So this is the formula for finding the midpoints of a and b, a plus b over 2. And finally, so a new point will be achieved here. In figure you can simply see, okay, this is a and this is b, and midpoint of a and b lies somewhere either towards this side or towards that side. So this is the actual root of the equation, and the mid value may be either towards this side or towards that side or exactly at the midpoint. We don't know whether it lies on the on this point or not. So if the midpoint of a and b exactly lies at the midpoint in such a way that the function value is 0, then this is the root of the equation. No problem on that. So if f of c equals 0, where c is the midpoint of a and b, then problem is solved. Then of course that c is the root of the equation. As previously I said, a point at which functional value equals 0, then that should be the root of the equation. So if f of c equals 0, then c is the root. No problem on that. But if f of c is not equal to 0, then we should check something else. Then first condition, if f of c into f of a is positive or greater than 0, that means if f of c and f of a both have same sign, then see here, f of a is this, and f of c suppose lies towards this side. This is the root, lies towards that side, this side. Then of course both f of a1 and f of c would have same sign. So it is no meaning of taking this point a1 in our calculation. So let us forget this a1 and let us move this point a to the point where c lies, because both have same sign and our requirement is we should have 2 points in such a way that at those points functional value should be negative. Functional value should be opposite. One should be of positive and another should be of negative. So this A is moved to here. I have explained that thing in here. So yes, so if both have A and C are those points in such a way that f of A and f of C has same sign, then simply that A is replaced by C. So that means in another word we can say that this point A is moved to the point where C lies. Okay, maybe somewhere in here. Okay, so now we have new A, that is a point C, and old B. So again here should be A and here is B. Again we will find the midpoint of A and B. Okay, and we find midpoint of A and B, and we check f of C equal to 0 or not. If f of C not equal to 0, we again repeat the same process unless we get f of C equals 0 and C would be the root of the equation. So this is the case when f of C and f of A both have the same sign. Now if this does not happen, and if f of C also not equal to 0, then we may have next condition, that is f of C and f of B would have same sign. On the graph you can see if C does not lie towards this side from the root, then of course that C may lie towards this side from this root. So now if that midpoint lies towards this side, then there is no point of being this point. So we move B from here to the C. So now we will have new B and A, and again from this new B and A we will find midpoint unless we get the value in such a way that f of C equals 0. That means we replace B by C and we again find the midpoint and we check f of C is 0 or not, and this process is continued unless f of C equals 0, and finally we get the root of the equation. Okay, this is the algorithm. Now we will move to the programming in Fortran. Okay, for that first of all let me open terminal, Control Alt T, and yes, this is our terminal, and we will move to the desktop and we do programming on the desktop. So inside desktop let me open document editor. I will name it as bisection.f90, and to continue running in background I will insert end here. Okay, this is my document editor, and let me start the program. Okay, first we write program, and we should write the name of the program, and that let me write name as bisection. Okay, this is the program and end here. So this is our format of the program. Okay, and yes, to which function we are going to find the root of the equation. Okay, so to find root of some function, simply we can write this function or another simple function. To understand it clearly, we will use this function. Okay, our function would be 3x minus 1, and we want to find the root of this equation within this interval. So let me define this function in our Fortran code. Okay, I will copy this terminal. Yes, to define function I have to insert real function, and name of function is f of x, end. This is the format of the function, and our f is equal to 3x minus 1. Okay, so this is our function, and I should insert into x 3x minus 1. So this is my function, but here as simply you can see here x is a real variable, and I need to define that as real. okay, so I completed function. Now to call this function inside the program, I need to insert real external here. Yes, this is defined for calling the function defined outside the program. So I have named function as f. Now yes, this is what our program is now. Yes, so our algorithm is, you can simply do programming just by looking algorithm. Okay, yes, algorithm is first give input a and b. So let us give input print, and this is the format of the print. Please insert the value of a and b in such a way that functional value at this point is opposite. Okay, so this is what we are going to print on the screen, and the person will insert the value to yes, read that by computer. We write a and b here. Okay, so I used a and b as real variable, so it is better to introduce that real variable on the program as well. So b, a and b. Okay, so we inserted a and b. Now next is find midpoint of a and b. Okay, so let us find midpoint of a and b. For that we need to define that as a and b. Yes, as c equals a plus b. Okay, I need to include this inside bracket divided by 2. So this is our midpoint of a and b. Okay, and next algorithm is check if f of c equals 0 or not. Then yes, okay, sorry, I introduced c as the midpoint of a and b, but I need to introduce this as real variable over here. So please insert c over here. Okay, so I defined c as real variable. Now I need to check. So for that I need to write if f of c, yeah, I can give space over here, f of c equals 0, then what? Print, because if f of c equals 0, then c is the root of the equation. So print it as the root of the equation is c. Okay, so it will print c as the root of the equation. There is no problem. So we included first condition, but this always might not occur. Sometimes this happens, f of c and f of a would have same sign. In that case we need to write it if f of a into f of c is greater than or equal to 0. So this defines f of a into f of c space dot gt dot means greater than 0. Then previously I said there is no point of being point A, so we need to move this point A to this C. So for that A equals C. Okay, so A equals C, that means A is replaced by, sorry, C is replaced by A, and again the midpoint of A and B will be calculated. For that we need to have the same formula. So it is better to define the address of this formula as 10. Then A will be replaced by C, and again we will find the midpoint of A and B. So go to 10. That means now after substituting C by A, again midpoint is calculated from going from this formula. So go to 10 means again go here, find midpoint, and then again check if that equals 0, then that will be the root of the equation. So this will happen unless f of c equals 0. For that condition where f of a and f of c have same sign, that is either both have positive or both have negative. Okay, now if this does not happen, then what happen is, yes, f of c and f of b would have same sign. Now simply we can copy this and we replace this by b. Okay, yes, after this there is no point, paste it and remove this a by b. Then again, I think you should understand, if you understood clearly about this, then you will understand about this as well. So what I mean is, if f of b and f of c have same sign, then yes, that b is moved to the point c, and again the midpoint of b and a is calculated, and same process is repeated unless we get f of c. So if this both multiplication is greater than 0, then b is moved to the c, so we will have new b, and again midpoint is calculated between new b and a using same formula, and again we will check f of c equals 0 or not. For that, again after computing this, we need to go to here. Okay, that's why I inserted go to 10. So this process happens unless f of c equals 0. So this is the programming, and I have used if. So to complete if, we need to have int if. So this is simply one type of program. There are only three conditions: if f of c equals 0, or if f of a and f of c has same sign, otherwise f of b and f of c would have same sign. So computer itself will understand, so it is not necessary to write this. This can be replaced simply by writing else here. Okay, so this is our program. We simply can calculate the root of the equation by using bisection method, and this is our function, and we are asked to find the root of the equation in the interval a equals 0 to a equals 1. So this is our question. Okay, so let me save it by using Ctrl S, and then let me open here on the terminal. Yes, this is our terminal. So to compile that file, I need to insert the Fortran here, and file name is bisection .f90. Okay, so yes, so now press enter and it will compile here. End if statement expected at 1. So here is one error, f is not a variable. Okay, wait a minute. End if statement expected at 1. So maybe I have not inserted end if. So for that, let me go to the editor. Okay, the problem is, yes, here is no implicit none, and the Fortran is reading this f as something else, so I need to insert implicit none, and then yes, now let me save it, and then yes, and then run it. Okay, so now first let me compile this. Yes, so all error are now clear. Now let me clear it. Okay, now let us check our output a dot slash a dot out is equal to checking for checking output. Okay, please insert the value of a and b so that this should have opposite sign. Okay, we have given function as 3x minus 1, and our interval should be a as 0 and 1 as b. So the root of the equation is 0.33333, etc. Okay, our function was 3x minus 1, and if this equals 0, then x should be 1 over 3. Okay, now let us check whether our answer is correct or not by the help of calculator. So 1 over 3 is 0.33333. So but our answer is 0.3333343. So our answer is very near to the right answer. Of course, every process has some sort of errors, so this is our answer. And further, let us check another interval as well. For 3x minus 1, let us insert minus 10 as the lower limit and 10 as our upper limit, and again the answer is same. So whatever the interval is, we will have the same answer as the root, but make sure that the given interval should result the opposite functional value, that is f of a and f of b should have opposite functional value. So this is how we can simply calculate the root of the equation by using bisection method. Okay, so thank you so much for watching this tutorial. Please write some feedbacks, comments, etc. regarding the video, and as you know that the computation of something, some equation, is not free from the error. So the practice of doing this is also not free from error. So please, if you find any error on doing this, then please comment me on the comment section. Thank you so much for watching this video. Thank you.